Hi guys, my name is Ansari and you're watching the 51st tutorial on C programming, and today we will be talking about bitwise operators. So you already know what bits are. Bits are 1 and 0. And operators that act specifically on these binary digits, they are called bitwise operators. And we're going to be talking about a few bitwise operators in these tutorials. So first of all, how do you convert a decimal number into its binary form? So we already talked about this in our previous tutorial, and the decimal 8 is equal to 0.0001000. And how did I do this? Simple. Just simply multiply each digit with a power of 2 and start from the right side and move towards the left side. And as you move by one digit, increment the power of 2 and multiply it. So let me show you what I mean. Starting from the rightmost digit, I will do first 0 multiplied by 2 power 0, and then move leftwards 0 multiplied by and increment the power of 2, 2 power 1, and then move leftwards 0 multiplied by increment the power of 2, 2 power 2, and then move leftwards 1 multiplied by 2 power 3, and then keep on doing this. 0 multiplied by 2 power 4, 0 multiplied by 2 power 5, 0 multiplied by 2 power 6, and 0 multiplied by 2 power 7. And in the end, add them all together. So you will get the decimal value 8. So this is how you convert a decimal number into its binary form. Similarly, you can convert the decimal number 6 into its binary form by writing 0, 0, 0, 0, 0, 1, 1, and 0. So now first I'm going to talk about the bitwise AND operator. And this is the symbol of the bitwise AND operator. And first I'm going to write my 8 and 6. So 0, 0, 0, 0, 1, 0, 0, 0, and 0, 0, 0, 0, 0, 1, 1, 0. So now if you apply the bitwise AND operator on these binary numbers, if at least one corresponding digit is 0, then the result will be 0. So right here, since there are two zeros, the result will be 0. Since there is 1 0 right here, the result will be 0. Again, 0, and then here 0, and then 0, 0, 0, 0. So you have to apply the operator on each corresponding pair of digits. So now the answer by applying the bitwise AND operator on 8 and 6 is 0. Similarly, if you apply the bitwise AND operator on 6 and 4, so 6 is 0, 0, 0, 0, 0, 1, 1, 0, and 4 is 0, 0, 0, 0, 0, 0, 1, and 0, 0. So when you apply the bitwise AND operator on 6 and 4, you get 0, 0, and then since both of these corresponding digits are 1, so then a 1 comes as a result right here. And then 0, 0, 0, 0, and 0. So this, after applying the bitwise AND operator on 6 and 4, you get the final result, which is the decimal number 4. So this represents 4 right here. And now I'm going to show you that in my program. So right here, I'm first going to declare my integer variable a is equal to 8 and integer variable b is equal to 6. And then I'm going to apply the bitwise AND operator on 8 and 6. So a ampersand b. And this is the bitwise AND operator. So when I run this program, I should be getting the value 0. So there's a 0 right there. Similarly, if I apply it on 6 and 4, I will be getting the value 4. So there's the 4 right there. So this is the first type of operator. And now the second type of operator is the bitwise OR operator. And it is represented by a straight line, the bitwise OR operator. So again, I'm going to write my 8 and 6, 0, 0, 0, 0, 1, 0, 0, 0, and 0, 0, 0, 0, 0, 1, 1, 0. So when you apply the bitwise OR operator on 8 and 6, and I'm going to represent it by a small straight line right here. So this is my operator right here. So when I apply it on 8 and 6, So the condition of the bitwise OR operator is that at least one corresponding digit should be 1 in order to get a result 1. So since both of these are 0, I will get a 0. Now since this right here is 1, so when I apply the bitwise OR operator on this pair of digits, I will get 1 right here. Similarly, I will get a 1 right here and a 1 right here and 0, 0, 0, 0. So applying the bitwise operator on 8 and 6, I got the value 14. So let me just show you that on code. I'm going to change this to 8 and I'm going to change this to 6. And I'm going to change the operator to the bitwise OR operator. And when I run this program, I'm going to get the output 14. And now another type of operator is the left shift operator, and it simply shifts your binary number to the left. So now the left shift operator this is the symbol of the left shift operator, just two angle signs. So I'm going to write my 8 right here, again 0, 0, 0, 0, 1, 0, 0, 0. And now when I apply the left shift operator on 8, and suppose I want to shift it by 1 bit, so I'm going to write 1 right here, and this will shift leftwards by 1 bit. So it will become 0, 0, 0, 0, 1, 0, 0, 0, and an extra 0 will be added here. So now this value becomes 16. Similarly, if I want to shift my number by 2 bits, so it will add 2 new bits to the right side and it will become 0, 0, 0, 0, 1, 0, 0, 0, 0 and 0. And this answer is equal to 32 in decimal form. So let me show you how the left shift operator works. So I'm going to add my left shift operator right here, and I'm going to change this to 1, and I'm going to remove my variable b from my program. So when I run this program, I should be getting the value 16 in my output, and there's a 16 right there. Similarly, if I shift it leftwards by 2 bits, I will get an output equal to 32. And this is right here. So this is the leftwards shift operator, and then there is the rightwards shift operator, and it is represented by 2 angle symbols pointing to the right side. So again, I'm going to write my decimal number 8 and its binary form is 0, 0, 0, 0, 1, 0, 0, 0. And now if I want to shift my number rightwards by 1 bit, so simply what will happen is that this 0 will be removed and my final result will be 0, 0, 0, 0, 1, 0, 0. So it has been shifted rightwards by 1 bit, and this right here will evaluate to the decimal number 4. So let me just show you the shift rightwards operator. I'm going to write this right here, its symbol, and I'm going to shift it rightwards by 1 bit. So when I run this program, I'm going to get a 4 in my output. And now the final type of operator is the complement operator. And those of you who haven't studied ones complement yet, so it might be a bit confusing, but I'll try my best to explain it. So again, the complement operator, okay, before that I'm going to talk about one more operator, the XOR operator. And the XOR operator is represented by this power sign right here. So again, I'm going to write my 8, 0, 0, 0, 0, 1, 0, 0, 0, and then I'm going to write my, let me write 5. 0, 0, 0, 0, 0, 1, 0, 1. So now this XOR operator, if the corresponding digits are different, then the result will be 1. And if the corresponding digits are same, then the result will be 0. So since 0 and 1 are different, I will get a 1 right here. And since 0 and 0 are same, I will get a 0 right here. And since these two corresponding digits are different, 1 right here, 1 right here, and 0, 0, 0, 0. Similarly, the XOR operator applied on two corresponding one digits will give me a 0 because they are both identical. So this right here is equal to 8 plus 4 12 plus 1 13. So let me just again write my int b is equal to 5, and I'm going to apply the XOR operator on a and b, and I will be getting the value 13. Okay, so now let's talk about the bitwise complement operator, which I was going to talk about before this operator. So the bitwise complement operator uses the ones complement. And if you guys haven't studied ones complement right now, I suggest you skip it. But those of you who are interested, then continue watching this video. So I'm going to write my integer 8. This is in decimal form, and in binary form it will be 0 0 0 0 1 0 0 0. So now when I apply the complement operator, so it's represented by an exclamation mark, and I'm going to apply it on 8. So what will happen is that all the bits will flip. So it will become 1 0 0 0 1 0 0 and 0. And okay, no, sorry. So it will become 1 1 1 1 0 1 1 and 1. So all the bits just flipped. And now in order to evaluate this last bit is the sign bit. So it tells us that this binary number will represent a negative decimal. So simply what you do is that the second last digit right here, you multiply it by the negative sign, so it will become minus 64, and then you add plus 32, and then you add plus 16, and then you add plus 4, and then plus 2, and then plus 1. And this will evaluate to minus 64 plus 32, minus 32 plus 16, minus 16 plus 4, minus 12, plus 2, minus 10, and plus 1, minus 9. So this right here, when you apply the complement operator, the bitwise complement operator on the number 8, this will give you the result minus 9. And those of you who are confused about what's happening right now, don't worry about this. You can skip this if you want, and if you want to learn more about this, then you can search it up on Google. So let me just apply the bitwise complement operator on A, and I'll show you the result. So let me add my exclamation symbol right here, and when I run this program, I'm going to get a minus 9 in my... Alright, now there's a slight issue right here. Alright. Oh, sorry. The complement operator is not represented by the exclamation sign. I forgot about that. The complement operator is represented by the tilde sign. So it's called tilde. And it might be at the leftmost side of your keyboard. So forget about the exclamation sign and add tilde sign right next to your number. So let me just fix this right here, and let me add my tilde sign. So I'm taking the complement of my number 8. So when I run this program, I'm going to get the output minus 9. So this is all it about the bitwise operators. If you have any questions, please ask them in the comment section, and thanks for watching this video.